Good morning to all, and welcome to this technical session 3. And on behalf of the organizing committee and my co-chair, I welcome you all once again. And as Dr. Narendra has already instructed you, this is a competitive presentation. So every presenters are requested to be stick in the time. Okay, total 10 minutes will be allotted to each. Okay, if you will exceed the time, number will be deducted on your credit. So be in time and so first presenter is Vimal Kumar.
Hello. Okay. Good morning, all of you. Myself, Vimal Kumar. I am here to present my work entitled as Malvaricon A, a natural compound showing potent anti-cancer activity against triple-negative breast cancer cell line MDMB 231. This work is done under the comparative guidance of Dr. K.V. Radhakrishnan or Dr. Kastukumar Maiti, Organic Chemistry Section, CSIR, NIST, Trivandrum. So, a brief introduction, why we use natural products. According to a study to Newman in 2020, about 53.3% of the FDA-approved cancer drugs are either natural products or naturally derived molecules. So, from this data only we can see the significance of natural product in the drug discovery. So, natural product can be classified into primary metabolites or secondary metabolites based upon its function, and based upon its origin, it can be classified into plant-derived natural products, microbial-derived natural products, marine-derived natural products, and animal-derived natural products. Some of the examples of drugs from natural products are heroin, vinblastine, penicillium, epibacterium. So cancer, it is one of the life-threatening disease developed through multi-step process. Some of the reasons for cancer are activation of oncogenes, malfunction of tumor suppressor gene, or mutagenesis due to external factors. The hallmarks of the cancer cell line are sustaining proliferatory signals, inducing angiogenesis, evading growth suppressor, resisting cell growth, enabling replicative immortality, and activating invasion and metastasis. Currently, the treatment available for cancer are chemotherapy, radiotherapy, surgery, hormone therapy, immunotherapy, and targeted drug therapy. So these are some of the statistics of cancer in India. Here we can see that breast cancer, which is around 27.5% occurrence in Indian women. So molecule of interest, malvaricons, they are the phenylacyl phenols or the diaryl nanoids. So we are considered for malvaricons, malvaricon A, malvaricon B, C, and D. These are the marker compounds of Myristicaceae family, and the common example of plants which we can isolate these compounds are Myristica malvarica. The compounds we used for these studies are isolated from Myristica fetua and Myristica badomi. Some of the pharmacological activities of malvaricons are described here. So first of all, for the primary screening, we have done the MTT assay for all compounds malvaricon A to D. We have done it in the two breast cancer cell line MCF7 and MDMB 231, and also two normal cell line WA38 and MCF10A. From the result, we can see that malvaricon A in MDMB 231 at the incubation time of 24 hours showed maximum toxicity at 8.2 micromolar IC50. So for the further studies, I was selected malvaricon A at an optimal concentration of 8 micromolar. So compared with the normal cell lines, we can see that the IC50 of normal cell lines are much higher than the IC50 in the cancer cell lines. So we can say that this malvaricon A induces higher toxicity in cancer cell line, especially in MDMB 231, and that is not much toxic in the normal cell line W39 and MCF10A. So first we have carried out the acridine or ethylene bromide live blood assay. Here we taken 6 micromolar as the lower concentration, 8 as our optimal concentration, 10 micromolar as a higher concentration. In the right hand bottom side we can see the control. So compared to the control, we can see that there is an increase in the number of apoptotic cell, which is indicated by the red color. We can see it at 8 micromolar concentration of malvaricon A. Almost half of the cells are red stained, which indicating the occurrence of apoptosis. So next, we have done the APOP assay to check the membrane integrity. In here also we can see that compared to the control, as the concentration increase, the pink colored cells are the number of pink colored cells are increasing, which indicating that the membranes are compromised by the treatment of our compound. Next, we have done the Histo staining. Histo is a nuclear stain. So it will give a bright fluorescence when it is bind to the nucleus, so the DNA. So here also we can see that compared to the control, as the concentration increase, we can see that the brightly fluorescent cells are, the number of brightly fluorescent cells are increasing, which indicating that the compounds are affecting against the apoptosis. So next we have done the DNA laddering. DNA laddering is a distinctive feature of DNA degraded by the caspase activated DNAs. Here we can see that there is a concentration dependent DNA degradation. In the control 6, 8, and 10, we can see that there is a clear formation of fragmented DNA bands. So this DNA fragmentation shows that this may be due to apoptosis. Next, we have checked the caspase activity. So we have taken caspase 3, 8, and 9. In the case of caspase 3, you can see a 8.93-fold increase of caspase 3 compared to the control. And in the case of caspase 9 and 10, we can also observe a fold change of 2.41 and 3.16 in caspase 8 and 9 respectively. We have used a concentration of 80 micromolar. So the increase in caspase 8 and caspase 9 indicating that both intrinsic and extrinsic pathways of apoptosis are involved in the action of Malabaricum A. Next, we have checked the FITC annexin 5 assay. Comparing with the control, the late apoptotic cell, which was 7.3 in the control, which increased to 38.6 and 15.4 when treated with 8 and 10 micromolar concentrations. So next we have checked the cell cycle assays. Here we can see that the accumulation of cells when treated with Malabaricum A, there is a increase in the accumulation of cell in the sub G0 phase. From control, it is 5.3%, which increased to 46 and 59.4% when treated with Malabaricum at concentration of 6 and 8. So in conclusion, among Malabaricum A showed most prominent result in triple negative breast cancer cell line MDMB 231, and different assays are confirmed to show the toxicity of Malabaricum A in the selected cell line, and we showed a potency in MDMB cell line. So the mechanism of action is under study. Thank you.
Any questions from audience? No questions?
How you use this as extract, like a water soluble, or what is this? Malabicon.
Sorry, sir.
Dissolve in what solution? This natural compound.
Yeah.
How you dissolve it?
Dissolved. Yeah, it is in less than 1% DMSO plus water.
It's fully dissolved.
Sorry, sir.
You get dissolved fully?
Yeah, it dissolved. It only dissolves in a DMSO. Then we make up with water.
Okay. So did you use any control, SAM, without only using DMSO and not using this compound to make sure that DMSO is not causing the death of the cells?
Yeah, we have checked the final concentration of DMSO. We just showed less than 1%. So we carried out with that proportion.
Okay. Mr. Vimal Kumar, I have a small query.
Okay.
Okay, and in your MTT test, you have started your test from 24 hours. What is the logic behind starting your MTT test from the 24 hours?
So actually I have tested 24 hours and 48 hours.
Why? Why not the 0 hour? Why not the 10 hour? Why come to the 24 hours?
Yeah, a prominent result was showing from 24 hours only.
Have you done any preliminary work on the basis that you can say we can start this MTT from 24 hours, not on the 23rd hours and 22 hours?
So we have visually checked it whether the cells are any undergoing any changes. So after around 16 to 18 hours, we can see any morphological changes.
Which test you have performed for that?
No, not test, just observing through microscope. Just observing through microscope.
Just observe the microscope, and you hypothesize that you will start from the 24 hours.
Yeah.
Okay, fine. And you have used this malabaricone A in the triple negative breast cancer cells. Whether this compound is has shown the same efficacy in the other cancer cells, or it is specific to the breast cancer cell line? What do you say?
So I have checked several cell lines, HeLa, A549. They are toxic, but the IC50 is around 40 to 50. Not as toxic to MDMB.
Okay. Any question? Any question from audience? Okay, fine. Thank you, Mr. Vimal Kumar.
Our next speaker is Eugenia Peterson from Rajiv Gandhi Center of Biotechnology. You can start.
Good morning, everyone. I am Regina Peterson from Rajiv Gandhi Center for Biotechnology. I'll be presenting the topic evaluating the phytosaponin utrocyte B as a candidate drug molecule against non-alcoholic steatohepatitis, also known as NASH. So NASH is basically characterized by excessive accumulation of lipid droplets within the liver, along with inflammation and cell injury, and it may even lead to end-stage liver diseases like chronic, cirrhosis or even hepatocellular carcinoma. So in our lab, we isolated a compound utrocyte B from the methanolic extract of the leaves of the plant Solanum nigrum, and we found that the compound exhibits remarkable therapeutic efficacy against liver cancer. And we also found that this compound is more potent than sorafenib, which is the most studied FDA-approved drug against liver cancer. And our compound was also granted patent by the USA, Canada, South Korea, and Japan. And we also recently received the orphan drug designation in the treatment of liver cancer by the US FDA. So in order to study the therapeutic efficacy of utrocyte B against NASH in vitro, we treated HG2 cells with a free fatty acid composition containing palmitic acid. And we observed that palmitic acid at a concentration of 0.1 millimolar is able to induce the deposition of lipid droplets within HG2 cells. And when we co-treated these cells with utrocyte B, we were able to observe a decrease in the deposition of lipid droplets. And further, AMPK is one of the major kinases that is extensively studied in metabolic and physiologic processes. And it has also been reported that dysregulated phosphorylation of AMPK is often associated with many of the chronic diseases like obesity, inflammation, diabetes, and also in the case of NASH. And in a previous study from our lab, we reported that utrocyte B has the potential to phosphorylate AMPK at the threonine residue 172. So we wanted to check if utrocyte B can do the same in HG2 cells treated with palmitic acid. And we observed that, in fact, utrocyte B at a concentration of 100 nanomolar is able to induce the phosphorylation of AMPK in HG2 cells treated with palmitic acid. And it is also able to reduce the expression of its downstream protein, FASN, that is fatty acid synthase, which is a key enzyme involved in the process of lipogenesis. So this suggests that this could be the mechanism by which utrocyte B is reducing the deposition of lipid droplets within HG2 cells. And in order to study the therapeutic efficacy of utrocyte B against NASH in vivo, we used the animal model, we used mice from the strain C57BL6, and they were fed with a high-fat diet for a period of 6 months. And for the treatment group, we administered utrocyte B at a concentration of 10 mg per kg 3 months after feeding the high-fat diet. And these are the representative images of livers of mice from the different groups. As you can see, in the control group, the liver has a more bloody appearance, and it's also smooth in its texture. And in the case of the high-fat diet group, the liver is more pale in color, and also it has a rough texture. And when you take the case of the liver from the treatment group, it has more resemblance with that of the control group. And this actually suggests the efficacy of utrocyte B in combating fatty liver. And we also monitored the liver to body weight ratio change in all of these groups. And we did notice some changes, but it was not that significant. And so these are the main histopathological features that are associated with the progression of NASH to HCC, that is steatosis, inflammation, ballooning of hepatocytes, and also fibrosis. And in our case, we were able to identify or observe almost all of these features in the high-fat diet group. So, and also in the treatment group, as you can see, Utrocyte B was able to improve the histopathological features in all of the mice. So here you can see that Utrocyte B has reduced the ballooning of hepatocytes, and it's almost similar to that of the control group. And here you can see Utrocyte B reduces the accumulation of collagen around portal veins, and it also reduces the lipid deposition within the hepatocytes. Further, we also conducted a pharmacologically safety evaluation of Utrocyte B in vivo by studying the histopathological features and also the serum biochemical parameters. Here we saw that Utrocyte B is not altering the liver enzyme levels or the parameters that come under the renal profile, and which again suggests that Utrocyte B is safe in vivo. And based on these promising results that we observed in the animal studies, we conducted pharmacological safety analysis of Solanum nigrum leaves containing Utrocyte B in healthy volunteers and also in patients who are undergoing Ayurveda and naturopathy treatments for various liver-related disorders. And so the patients, the participants of the study, they were given capsules of Solanum nigrum leaves in a powdered form, which contains an IC50 concentration of Utrocyte B. And we monitored changes, and we monitored their liver enzyme levels and also their renal profile 1 month after the consumption of the capsule. And we saw that in the case of healthy volunteers, the liver enzyme levels and the renal profile parameters were stabilized well within the reference range. And in those individuals who already had these values beyond their reference range, after 1 month of consumption of the capsule, these values started coming down. And we also had a few patients who were diagnosed with chronic liver diseases. And we saw that after consumption of the capsules, even their levels of liver enzymes started decreasing gradually. And it was also reversed to the stage 1 fatty liver. So this study gives us promising results, which may aid in the treatment of liver-related diseases in the future. So in conclusion, we can say that Utrocyte B is a promising candidate for Utrocyte B is a pharmacologically safe compound, which should be evaluated as a candidate drug against non-alcoholic steatohepatitis and also in preventing its progression to liver cancer. Thank you.
Any questions from audience? Okay. Pragna, tell me one thing.
Yeah.
You have given the leaves to the patient.
Patients, yeah.
So how you make sure that how much leaf they are eating and how much actual content is going in the patient?
I didn't get.
So how much leaves you give them to eat? What is
it's like we shade dry the leaves. We add shade dry the leaves and powder them, and we make the leaves. We give the powdered capsules around 450 mg of the powdered leaves in capsule form.
How much is active UTTB in that powder?
This powder, it contains active concentration. That is, this powder contains concentration which is equivalent to the IC50 concentration of Utrocyte B.
Was there any SAM group where you given capsule without this extract? There was any SAM group, control group, where no capsule was given?
We don't have a control group in the patient study because it's basically a toxicity analysis. We are only evaluating the pharmacological safety of the drug. So in that, we cannot actually ask the patient, like we have healthy volunteers. So we cannot ask the patients to stop taking their normal medicine. It's unethical. So it's just a pharmacological safety analysis, not exactly studying the efficacy of the compound.
So did you study in the mice model, some model?
Yeah.
Okay.
Yeah. I showed you them. In the mice models, we are giving control high-fat diet group and also treatment group.
Okay, this is the same question I'm also want to know. And as you said, you have given the leaf to some patients.
Yes.
Okay, for leaf powder. And did you perform the same experiment to your model animal?
Yes, I haven't given the data. We have given the extract of the leaves in animal models also.
Now,
So based on that only we moved.
how
on
do
to
you
patient
know
study.
the extract is entirely of this uterocyte B?
How do we know that?
How do you know this extract? You have in as that it may be the crude extract, isn't it?
Yeah.
Okay, how do you know that how much percentage of that uterocyte B is there in that crude?
See, we have actually done the basic study in vitro model, and we got an IC50 of 500 nanomolar. Based on that only we calculated, like in animals we have to give around 10 mg per kg. So likewise we calculated in humans also.
Have you done any GCMS or NMR for characterization of the different compound may be present in the crude extract?
Yes.
It doesn't mean that leaf is 100% of uterocyte B.
Okay,
maybe the other compound is affecting that. How do you nullify this compound which is present in that leaf?
See, different compounds are present in the leaf also. Uterocyte B, uterocyte A, utronin is also present in this leaf. I mean, Solanum nigrum. But we are giving the patients the extract, considering that uterocyte B is also present in it. So whatever the effect may be, like we are also getting similar effects when we are giving the drug alone in animal models. So definitely it must have some effect. And uterocyte B is also water soluble compound.
What is the sample size you have used for this particular type of study for humans?
Humans, so it's only a pharmacological safety analysis. It's not
No,
a proper.
you are
clinical
giving
trial.
this hypothesis that we have given this compound to the patient. Okay, and you find the status of the liver has been increased and maintained.
Yeah.
Isn't it?
Yes.
And my question is how many sample size on the basis of that you can say, yes, this compound is the responsible for impairment of liver.
Okay. So we have around 80 patients enrolled in 80 volunteers enrolled in the study. And among those, around 25 of them are diagnosed with fatty liver disease. And around 54 control patients. And we also have HCC patients in the study. So, so they are also showing positive results. Around 10 to 15 HCC patients.
Okay, and you have not done the same experiment in the rat mice?
Yes, we have.
And
like,
any correlation between the two model system?
We are observing similar results. Similar results as in the mice level, we are conducting toxicological analysis and we are getting similar results. That is, there is no alteration in the levels of liver enzyme or in the kidney profile. And in the HCC models also, we conducted the study, and uterocyte B as well as the extract of Solanum nigrum is able to reduce the tumor size in HCC models.
Okay, this in the human model, you have used only some important liver-related tests on that one basis of that. But in mice, you say you have done the toxicity effect of this compound.
Yeah.
Okay, how you correlate with this two? One is toxicity test, another is efficacy test of the compound. How you correlate with both?
We have done toxicity and efficacy test in the mice model. And we are doing toxicity study in humans as well.
You have not done the toxic study in the human?
Pharmacological safety analysis in humans.
Okay.
That's what we are doing.
Okay, fine. Any question?
Great work. I just wanted to know, how did you feed this compound to the mice? Because I assume since it is, you later clarified it is water soluble.
Yeah.
So did you mix it directly with the food, or did you?
We gave IP administration.
Okay.
The drug was dissolved in PBS, and then we gave it as IP administration.
Did you try mix, because you said it is hydrophilic, you yourself said it. Did you try mixing it in that concentration in the food and feeding it and seeing?
No, we haven't mixed it with the food and fed the animals, but we have tried oral delivery of the drug.
Oral delivery.
Yeah.
That is with a vector.
That is?
With a vector, in that case, if it is an oral delivery, how did vector gets?
Oh, the vehicle.
Vehicle.
In PBS.
And in humans, I think, said with capsules.
Yes.
Okay.
And also it's important that the drug is dissolved in an alkaline medium. That is why we are giving PBS. And even in humans, we are asking them to consume the capsules in an alkaline medium, maybe the juice of cucurbitacin group products. Thank you.
Okay, so my question is, how did you purify the utrocyte B? Like, did you purify it, the utrocyte B? How did you purify it? Like,
The purification part was done early by my seniors. It was done in collaboration with the scientist from CSI and NIST, Dr. Ravi Shankar. So we did the characterization at NIST.
okay.
Next presenter, Pratibha Agnihotri is there. Yeah, please.
Good morning, everyone. First of all, I would like to thank the organizers of INCD for giving me this opportunity to present my work. I am Pratibha Agnihotri, Senior Research Fellow at ICMR National Institute of Cancer Prevention and Research under the supervision of Suresh T. Hidao, working on a DHR-funded project. The topic for my today's oral presentation is to explore molecular signature in mTOR inhibitor-resistant triple-negative breast cancer. Since breast cancer has been the most prevalent cancer amongst the other types of cancer, according to the Globocon report 2020, the number of new cases in 2020 at amongst all ages in both the sexes is around 11.7%. Breast cancer has been divided into two parts based on the nature. In situ carcinoma that is restricted to only a particular location, and it has been further divided into ductal and lobular according to its location. Whereas invasive carcinoma, this is very spreading in nature and it spread throughout the other breast tissues. And it has been further divided into, again, invasive lobular carcinoma and invasive ductal carcinoma. This invasive ductal carcinoma has the relative incidence of about 64%, and it has been further divided into luminal and basal-like based on the molecular classification. Since luminal A and luminal B has been the subcategory of luminal, luminal A has the hormone positive and HER2 negative expression, whereas for the luminal B, it's hormone positive and HER2 positive. And it accounts about 66%. Whereas basal-like carcinoma, it is further divided into TNBC and HER2, where TNBC is triple negative breast cancer, which has all the expressions in negative, like hormone negative and HER2 negative, but the expression of CDK5 and 6 and EGFR is positive. Whereas for the HER2, this is hormone negative, but HER2 positive. Oops, it's not open. The second. So can I connect my laptop, because there was one slide which is not visible in this. Can I? Thank you. Sorry for this technical issue. I actually can we shift this? It's okay. Okay. So talking about the breast cancer management, there are basically 4 types of managements, that is radiotherapy, chemotherapy, targeted therapy, and surgery. Targeted therapy has been divided into immuno-based and small synthetic kinase inhibitor. We have basically I have worked on two drugs, everolimus and rapamycin. Rapamycin is a macrolide compound which was approved by FDA in 1999 for basal-like cancer, and it was discovered by Ayers Research Laboratories, whereas everolimus is the derivative of rapamycin, and it was approved by FDA in 2012 for hormone-positive and HER2-negative cancer types. It was developed by Novartis. Now, when we talk about how a sensitive cell and how a resistant cell works, the drug in sensitive cell, these drugs, they target the mTOR. PI3K-AKT is the intracellular signaling, which is responsible for the cell survival signaling, like cell proliferation, cell survival, cell death inhibition, protein synthesis, autophagy, and hypoxia and nutrient deficiency sensing, angiogenesis as well. So these drugs directly target to the mTOR, so those signaling cannot occur, and that's how the cell dead. And it is being sensitized to these particular drugs. But in the resistant cell cases, these drugs either get inactivated, or there may be any kind of epigenetics which is not led these drugs to act on these mTOR, or there could be a drug target alteration and DNA damage repair. So the cell will continue to grow, and this is how the tumorigenesis still continues. And this is actually a case where they acquire this therapy resistance, and that has been a major limitation in therapeutic management of breast cancer. The rationale behind this study is we need to find out the molecular mechanism which is responsible for this acquired drug resistance mechanism, and it is still inadequate in our present study. And also to identify the prognostic markers for the selected targeted therapy, which is not still known, and we need to address this problem and for the selection of a better treatment. The aim of this study is to explore the acquired therapeutic resistance molecular mechanism in TNBC, and to identify a set of prognostic markers as well as a new drug targets which we can use for an alternative therapy to this cancer. The methodology that we have used is, first we have cultured and maintained the MD-MB231 cell line, and we have evaluated the drug efficacy through MDT assay. Then doses escalation and continuous treatment, we have developed a cell model which is resistant to these particular drugs. After that, we have evaluated the resistance by cell-based assays like MTT assay, wound healing assay, clonogenic assay, and reactive oxygen species detection assay. Then when we have to work on the molecular assays as well. And then we have, after confirmation of these drug-resistant model, the future work plan is to study the biomix study to explore the molecular mechanism behind it. And through the integrative analysis using this microRNA profiling, mRNA profiling, proteome profiling, and phosphoproteome profiling, we're going to find out the set of prognostic markers that we can use in our alternative therapy. And after that, we're going to do the validation in the clinical samples as well. So while doing this cell-based assay, we have found that through MTD assay, the cell viability assay of these drugs showed in 24 hours of treatment very high rate of IC50, that is around 45 to 50 micromolar. But when after the 48 hours of drug treatment in control as well as in the resistant cell line, we have observed that for the control cells, EV showed 0.25 to 0.5 micromolar of IC50, whereas for the rapamycin, it showed about 0.5 micromolar. Similarly, in the resistant cases, for everolimus, they have showed 15-fold of change, and for rapamycin, it has showed about 20-fold change. In the case of wound healing assay, to find out the cell migration efficiency of these cells under the treatment, we have actually maintained and cultured our control cells under the drug treatment for 0, 12, and 24 hours. And we found that these control cells have completed its gap distance within 24 hours. But for the resistant cells, even under the treatment, they have not showed the full gap filling. Similarly, in the case of the rapamycin, also the control cells in the drug treatment won't be able to control that to fill that whole gap. Whereas with the rapamycin resistant cells, there was some sort of gap distance which we have observed. And through the graph, on the right side, you can see there is a depiction of what is the gap distance that has been visible here. Then the clonogenic assay. This clonogenic assay, we have calculated number of the colonies and number of the size that we have done, and similarly we have found that the resistant cell line showed equal amount of colonies and colony size according to the control. Then we have also performed the ROS generation assay because cell produces stress under the condition, and this ROS also showed that in control cells there is a more production of ROS in 15 and 20 micromolar, but for the resistant cell lines, there was a very minute level of ROS which has been observed. And the same graph has been depicted representing the percentage of ROS intensity. So the conclusion is that TNBC resistant cells showed a survival, enhanced potential and aggressive proliferation and migration tendency better than the control cells. And further molecular mechanism need to be studied. Where the future aspects is the challenge of this therapeutic resistance can be resolved if we can find out the molecular mechanism behind this resistance pathway, and we can, if we would be able to generate an alternative therapy in future for TNBC patients. Thank you, and these are my lab mates. So thank you.
Any questions from audience? Anyone can ask? No questions for audience? Okay. Pratibha,
Yes, sir.
your topic was to explore molecular signature in mTOR inhibitors.
Yes, sir.
Okay. And I have not seen the type of the title you have given in your presentation, the molecular signature in the mTOR. How you justify your title and the content you have presented?
Sir, actually, this is our future plan because we have developed the cell-resistant model, but we have to like find out the omics study also, because this is a
I
future
agree,
plan.
but this is competitive presentation, and the title should be reflect your presentation, and it is totally missing as per knowledge, because I am not from the cancer biology background. Okay,
Okay, sir.
so still I am not able to find out some molecular signature of the mTOR in your study.
I do agree with that. You told that you have developed some model of drug resistance, but I'm not seeing any model developed here.
So actually, in my methodology, I have used the drug doses escalation. That means I have started from a very low amount of drug, and after that, continuously I'm giving my control cells this particular drug treatment. And we need to confirm it. At cellular level, I have confirmed it using those S-cell based assays. But the next step would be find out the molecular signature. For that, I have to study this omics profile of these cells. So basically, this is just a confirmation for Sir point that molecular signature I'm going to do.
Hey, but what do you mean by developing a model, in vitro model? What is model?
So model is the control cell. Like I'm using MDMB231 cell. This is a TNBC cell, triple negative breast cancer. So this is my in vitro model.
So when you say when develop a model, it can be used by anyone else, like a 3D model, an animal model. This is not actually a model, it's just in vitro system, not a model, not a stable model. We're just developing a system where you're trying to see the resistance. But you can't use these cells. Can you reuse these cells?
Sorry, sir?
Can you reuse these cells after this gene treatment?
Yes, sir, because this is what, because I have started from the day one, I have started giving the treatment to my cells. And through different passage drug, and then that those cells were not, like, I'm not using it again. So I'm passaging it again through secondary passage, and still they are in a process. Like,
so once you take the final passage cells, will they be stable at that property?
Yes,
will be stable?
Yes, sir. They are still growing and they are in incubator also, right now also.
Okay.
They are there.
And there is one more suggestion for you. Don't have any p values in any of your graphs.
No, yes, sir.
You should have that to say whether it is significant or not.
Yes, actually, sir, I have
Just putting a standard bar and bar graph will not be enough.
Yes, sir.
Okay, thanks, Pratibha. Any more questions? We'll move to the next student. Next is Asim C. Rai from JNU.
Good morning, everyone. First of all, I want to thank the organizer for giving me the opportunities to present here. So myself, Ashim Chandra Roy, today I am presenting my topic is that comparative study of anti-cancer potential of two different traditional medicine plants, that is Rnas, Lips and Tubista Newton inflorescence in human hepatocarcinoma hereditary cell lines. So all of we know there is a classical correlation between the reactive oxygen species and the cancer progression. In the normal cells, the cells have certain amount of antioxidant enzymes that try to regulate the oxidative stress. But if somehow chronic oxidative stress is happening in the cells, and that may lead to the cancer formation. However, in this case, we can revert this situation by the therapeutic intervention of various natural antioxidants, including vitamin E, vitamin C, vitamin E, and as well as some synthetic antioxidants like NAC, selenium, etc. However, we can target the anti-cancer therapy by another way, that is the ROS elevation therapy, that includes chemotherapy, that includes radiotherapy, as well as natural and synthetic compounds. So on the basis of this classical relation between the ROS generation and the cancer progression, we have targeted two different medicinal plants so that they can alter or moderate the ROS level of the moderate the intercellular ROS level and show any effect in the cancer progression. So we choose the Tubista nutans and the Rolbus sabina. Tubista nutans is a less explored traditional herbs kind in India. It is predominantly found in the northeastern region of the India, that includes Meghalaya, that includes Sikkim, and also some part of the eastern West Bengal, including Darjeeling, Karshiang. Another part is the Rolbus sabina is most extensively studied traditional medicine plants that having various medicinal therapies, including fever, dengue, malaria, and as well as hypertension and high blood sugar. Tubista nutans also traditionally used for the blood sugar, fever, pain reliever, and as well as it is consumed by the locals as vegetables. So we collect the leaf of the Rolbus sabina and inflorescence of the Tubista nutans. We prepare the methanolic extract of this and then followed by lyophilizing and dissolved in the DMSO media for further experiment. So as our main target is that whether these two plants have any effect on the intercellular ROS or not. So we, at the very initial stage, we check the antioxidant property of these two plants. So first we did the in vitro antioxidants by DPPS radical scavenging method. And we found that at the concentration of 1 mg per ml, Tubista nutans actually scavenge 50% of the DPPS free radical. And as well as Rolbus sabina at the concentration of 100 microgram per ml scavenge the 50% DPPS free radical. So this proves that these two plants have the antioxidant potential. However, the Rolbus sabina showing the more higher antioxidant potential than the Tubista nutans. Coming to next, we check whether these plants have any antioxidant assay activity in hereditary cell lines. So upon treatment with the 100 micromolar of H2O2, the ROS level actually increases by 2 times in the hereditary cell lines. But following by that pre-treatment of 3 hours of Tubista nutans and Rolbus sabina at the concentration of 25 mg per ml, the H2O2 induced ROS generation actually prevented, as so because it had taken as a positive control. So both of the experiment proves that these two medicinal plants have some certain of antioxidant activity both in the in vitro and the in hereditary cell line. Coming to the point next, we check whether these two plants have any effect on the hereditary cell viability. So we treated the cells for 24 hours and we find that 100 microgram per ml concentration of Tubista nutans cause actually almost 40% of declining in cell viability, and Rolbus sabina causing 30% of the decline of cell viability. This is further confirmed by the phase contrast morphology, where we can see that the Tubista nutans causes the more distorted cellular morphology, as well as also showing the same kind of result. Pollen confirmed that formation is extracted group and then the control. I want to mention that all of the treatment I'm done with the 100 mg per ml concentration of the both of the extract. Further, we check the cell viability in the non-cancer origin murine and fibroblast F2+ cell lines, and we found that although all the Tubista nutans causes almost 20% of the decline in the cell viability in the fibroblast cell line, but this is significantly much lesser than the hereditary cell line, and also Rolbus sabina causing no impact on the cell viability of the in the F2+ cell line. So coming to the point is that as we know that our main target is to checking the ROS level of the cell in the healthy cell lines. So we check the intracellular ROS by DCPADI in fluorimetric method, and we found that 2% return actually causes the increment of the intracellular ROS at the time point of both 12 and 24 hours. However, Roll plus Sabrina showing the negative effect. It actually reducing the intracellular ROS level both of the time. So we can say that 2% return causing the oxidative, whereas Roll plus Sabrina causing the reactivity in the cell. Whereas mitochondrial membrane potential is in both of the cases negatively impacted. That is that indicating the mitochondrial depolarization, which can be indication of cellular death. Next, we check the intracellular calcium level and mitochondrial mass. First of all, we check the mitochondrial mass by the by the MTG fluorescence, and we found the mitochondrial mass is been reducing in both of the cases, whether irrespective of 12 hours and 24 hours. Also, intracellular calcium level is getting impacted mainly by the Roll plus Sabrina, but not by the 2% neutrons. Intracellular calcium, as we all know, that it can increasing level of intracellular can be leading to the mitophagy, can be leading to the apoptosis, necroptosis, and so on. So next we check what is the effect of this two drug on the cell cycle phases, and we found that 2% neutrons actually causes the G0G1 arrest, and as well as sub G0G1 population has been increased significantly. That indicate the apoptotic bodies. Also, Roll plus Sabrina also showing a similar kind of effect. It causes the G0G1 cell cycle arrest, and as well as sub G0G1 population has been increased. So next we check the nuclear morphology, and we found that 2% neutron causes actually nuclear shrinkage as well as cytoplasmic shrinkage. This is an indication of cell death. Also, similarly, Roll plus Sabrina causing the nuclear shrinkage, nuclear damage, and cytoplasmic shrinkage. This is also a strong indication for the cellular death. So, coming to my conclusion is that the comparative, if we analyze that in 1.2% neutron actually increases the ROS level, whereas Roll plus Sabrina decreases the ROS level of the healthy cell lines. Mitochondrial membrane potential and mitochondrial mass both are getting negatively impacted. Intracellular calcium level has been increased by the Roll plus Sabrina, but not by 2% neutrons, as well as nuclear damage has been occurring both in both of the extract. These all the evidential facts just directly indicating just one thing, that is for the cell death. However, the mode of cell death is yet to be investigated by us. So the main point is that all we know that Roll plus Sabrina have some kind of we all know somehow know the alkaloid present in the Roll plus Sabrina. The alkaloid may be reserpine, azithromycin, serpentine. These are all have therapeutic potential. But 2% as I previously said that it is a less discordant medicine. Recently we have published a communication where we find that 2% neutrons actually have a certain amount of anti-cancer molecules, including diazorin, which has been extremely studied in the cancer cell line. So this diazorin can be a possible reason for this anti-cancer property. However, I am concluding my presentation with this remarks that we all know that 80% of the people worldwide rely on herbal medicine for some aspect of their primary health care. And also plant drugs constitute as much as 25% of the total drugs in USA, and India it is about 80%. Also, India has a great history of the Ayurveda and traditional medicines. Almost 8,000 herbal remedies have been codified by the Ayush system in India. So with this take home message I want to finish is that let's plant medicinal plants and take care of it. This is good for our sustainable development of human health. Thank you for listening.
Hello, Asim Roy.
Yes.
Can you show your third slide? Third or fourth slide? Third slide.
Third slide.
Third. Yes. Okay. In this experiment, you have performed the antioxidant property of these two plant extracts. Okay. And if you see the graph in vitro antitoxic assay, and what's the reason behind that? You have used a different concentration of these two compounds. One you start from 5,000 microgram per millimeter, and another you start with the 50. Okay, this is the one my concern. Second question: all the experiment you have, which you have shown in your presentation is dependent on these two property of this antioxidant. Then how can you justify that the concentration of both are different with each other? Varied. Okay, one is 50, one is the just 100 times more concentration. What's the reason behind the two? Because compound, which compound is the responsible for anti-therapeutic treatment for the liver? Okay, you want?
So tell me one thing, you have lots of stars in your graphs. 2 star, 3 star, 4 star, 5 star. What are those stars? How much is that 5 star and 1 star? 5 star. You have up to 4 star something. What was the N number when you're doing the experiment? N number is okay. So which compound is better? If you have to use compound, which is better? So then how we can say that these have better anti-tumor effect? Yeah.
Hi, nice presentation. You have checked the ROS level.
Yes.
So you check the overall ROS level
Only,
or mitochondrial?
no, I'm not checking. Currently, we're not checking mitochondrial. We're checking overall intercellular ROSes. I think mitochondrial, there will be a better option. We are planning for it.
Okay, because you are linking to the mitochondrial
Yes,
mass.
mitochondria is more getting negatively impacted. So mitochondrial ROS would be a better option for us. We are looking forward it actually.
Thank you, Asim. So next speaker is Ashish Kumar from CMF Lucknow.
Good morning, respected professors, delegates, and researchers. I am Ashish Kumar, representing the CSIR CMAP under the supervision of Dr. Nirban Pal. Today, I am presenting the topic Withania somnifera defends guts through the modulation of innate and adaptive arms of immune system. So first of all, we will move towards the introduction. The largest number of immune cells than any other tissue or the organs of the body makes the immune system a largest immune system, makes the gut a largest immune system of the body. So mainly two types of immune systems are present in gut, which are broadly divided into innate and adaptive arms of immunity. Next is that the specially mentioned is that trillions of microbiota resides in the guts, which provide colonial resistance. So as our institutes works on the medicinal and aromatic plants, so we choose Withania somnifera for further study. So in the study, we mainly use the ethanol extracts of Withania somnifera. So about Withania somnifera, this is also called as Indian ginseng, ashwagandha, ashgandha. This is important medicinal plant in Ayurvedic system, described as Sattvic Kapha Rasayana. In Indian ancient scripts, the plant is used in inflammation, emaciation, weakness, neurological disorder, impotency, and plant is added into the Indian Pharmacopoeia as the official drug. Next is methodology. First of all, we will start with the in vivo methodology. The in vivo experiments were performed in the Balbisi mice. That was a salmonella typhimurium Balbisi mice model. The animals were divided into 6 groups, and each group contained the 6 mice. Group first was the control mice. Group second was the vehicle control mice. That is, group second mice were given only infection, no treatment. Group third mice were given only probiotics, VSL3. Group 4 mice were given Vithanes somnifera 250 at the rate Vithanes somnifera ethanol extract 250 mg per kg of body weight. Group 5 were given Vithanes somnifera 500 mg per kg. Group 6 750 mg per kg. We start the dosing of animal with all these doses from day 0 to day 28. At day 14, we immunized the mice with Salmonella typhimurium 10 to the power 3 CFU. On day 28, the animals were given a challenge dose of 10 raised to power 9 CFU orally. After that, 96 hours of challenge dose, we sacrificed the mice for the next studies. We collected the blood, spleen, and the ileum. Blood was collected for the analysis of TNF level, IFN, IL-10, circulatory IgA, and salmonella specific IgG. Spleen was collected for bacterial load calculation, and ileum was collected for the expression study of defensin, lysozyme, mucin 2 protein, TH17 response, TH1 and TH2 response. Further moving towards the spleen was homogenized, diluted, spreaded on the NA plate, and the CFU were enumerated. And from the ileum, we study the fold change in expression of different genes, as we mentioned, that is defensin, mucin, lysozyme, TH17 response, TH1. In vitro studies, we performed the chemokine assay on the CACO2 cells, that is colon epithelial cells. The cells were exposed with 10 to the power 8 CFU. In our calculation, it was 10 to the power 2 Salmonella typhimurium for each cells. The cells were washed and total RNA was isolated for the expression studies of chemokines, that is ENA78, Rnas, MCP1, IL6, and IL8. LPS induced study of macrophages were also performed. We induced the LPS with 1 microgram per ml of Vithanes 1 microgram per ml of LPS, and we treated the animal with different concentration of Vithanes somnifera ethanol extracts. Now moving towards the results, the effect of Vithanes somnifera on cytokines and chemokines. In LPS induced macrophages, the Vithanes somnifera significantly decreased the level of TNF and IL6. In CACO2 cells, the Vithanes somnifera significantly downregulate the pro-inflammatory chemokines, that is ENA78, Rnas, MCP1, IL6, and IL8. But the effective dose for all these expressions were Vithanes somnifera 10 microgram per ml. During in vivo study, the bacterial load were checked, probiotics, and the Vithanes somnifera all doses significantly downregulate the bacterial burden from the spleen. In case of humoral response, IgG were circulatory IgG were measured, IgG and IgA were measured in the serum samples. So IgG and IgA were significantly IgA were significantly downregulated by Vithanes somnifera 750, and probiotics also. Circulatory IgG were also increased in case of Vithanes somnifera and probiotics. The level of inflammatory cytokines TNF, IFN, and IL-10 were significantly downregulated in all the probiotics as well as in Vithanes somnifera ethanol extract treatment. Now towards the innate immune response and TH17 response. Innate immune response were measured by mainly mouse beta defensin, lysozyme, and MUC2 expression. Probiotics and Withania somnifera significantly significantly upregulate these upregulated the expression of these genes, that is defensin, lysozyme, and mucin. The level of pro-inflammatory cytokines, that is Th17 specific cytokines, IL-17 and IL-22, were significantly downregulated by the treatment. And next, the major anti-inflammatory cytokine, that is IL-10 in the gut, was also downregulated by the treatment and probiotics both. Now, pro-inflammatory cytokines expression were also measured in the ileum. That level of TNF, IL-1 beta, IL-6, and IL-8 were also significantly downregulated by Withania somnifera treatment and the probiotics treatment. Finally, moving towards the conclusion, that Withania somnifera modulate the LPS-induced inflammatory response in peritoneal macrophages. Withania somnifera control the overexpression against the bacterial-induced inflammatory response by the chemokines and cytokines in colon epithelial cells. Withania somnifera enhance the innate immune response to incoming pathogen by increasing the expression of defensin, lysozyme, and mucin. Withania somnifera also reduce the bacterial load in the lymphoid organ. Withania somnifera strengthen the humoral immune response by decreasing the IgA level and increasing the cellular specific IgG. Withania somnifera also normalize the Th17 response during the pathogenesis, and Withania somnifera modulate the cell-mediated response by downregulate the pro-inflammatory cytokines. Thank you. Keep your gut happy and healthy.
Ashish, very good talk. It was very clear.
Thank you, sir.
So you have used some 3 molecules, MCP1,
Yes, sir.
Rnas, and IL-17.
Yes, sir.
Can you tell me what is the connection between these 3? How they are linked?
How they are linked?
Yes.
Sir, actually, MCP and Rnas, these both are the pro-inflammatory chemokines. As the level of these chemokines increase at particular level, they attract the other pro-inflammatory cells towards the site of infection, and they induce the over-inflammation at that site. And in case of Th17 response, the Th17 response can be pro-inflammatory or can be anti-inflammatory. It only depends. It mainly depends on the level of IL-22, maybe, sir.
What will happen if IL-17 goes up? The Rnas and goes down, MCP goes down and goes up.
Rnas will?
Rnas and MCP1, how they are linked to IL-17?
How they will affect
How they are linked to IL-17? So the IL-17 level is going down. Go back. Yeah, this one.
This one.
Yes.
Yes, sir.
So there is a change of IL-17 when you're giving the treatment. How this is linked to Rnas and MCP1? Any connection?
Sir, actually, I am not getting properly your question, sir. How IL-17?
What is the role of IL-17?
Sir, actually,
let's talk in clear. What is the role of IL-17?
What is?
Role of IL-17.
Sir, if IL-17 is the major pro-inflammatory cytokines in case of inflammatory disease of the gut, mainly like IBDs.
Okay. It's a pro-inflammatory cytokine.
Yes, sir.
What is the role of Rnas and MCP1?
These are pro-inflammatory chemokines, sir.
Are they linked? Are they linked? If IL-17 goes up, they also goes up or goes down. Any idea?
Sir, these are the MCP and Rnas. These are considered in the innate immune response of the epithelial cells, but these are the cells mediated. Acquired immune response, sir.
Okay. And then.
Any question from audience? Okay, so I have small query, Mr. Ashish,
Yes, sir.
and you have done little part of work in the gut
Yes,
microbiota.
Sir, actually, the work is going on towards the gut microbiota analysis also, sir. 16S RNA analysis.
So, and a lot of work has been done on this ashwagandha. Okay. Ashwagandha, this plant,
Yes, sir.
Bithania is, I think, Ashwagandha, na? Kya naam
Plant is
uska?
ashwagandha, yes, sir.
Yeah. So a lot of work has been already done in the different parts of our country on using this plant extract for many different type of cure of the therapeutic treatment for many diseases.
Yes.
How your work is different and rationale of your work?
Sir, actually, the Vithan, this topic was very new for us, actually, especially for us. And mainly Vithan, we choose the Vithan. We actually screened more than 30 extracts, sir, from the 10 different plants. So we choose the Vithania somnifera and one other plant, that is Trachispermum emi, for the further studies, sir. The microbiota analysis study were not studied in the in recent past, sir. So we are going towards that direction also.
Okay, so you said this because microbiota upregulation and down regulation you have said, okay, by using this plant extract.
Yes, sir. Yes, sir.
Okay, you have used the many times. How can you say this is upregulation and down regulation? What do you mean by how you estimate this is upregulation is the down regulation? Increase and decrease is called as upregulation and down regulation according to you, and what you have seen all the gravitation upregulated, down-regulated immune systems are on the what basis you say this is upregulation?
Sir, actually,
have you done the gene expression of all
yes, sir.
studies?
Yes, sir. RT-PCR.
RT-PCR. How many experiments? Every experiment you have done the RT-PCR of this?
Sir, actually, a number of N were 6, and all the experiments were performed in triplicates also.
And all gene expression has been done in the all set of the experiment.
No. Actually, we have chosen some more genes, but we only get we have only mentioned that gene in which we get the expressions upregulated, sir.
Upregulated.
Yes, sir.
Okay, fine. Any questions from audience? Thank you, Ashish.
Thank you, sir.
Next presenter, please. Chanchal.
A very good morning to everyone present here. I, Chanchal Parija, is presenting today's talk on the topic elucidating the differential regulation of novel long non-coding RNAs and its mechanism of action in P73 dependent manner. So moving to my first slide, why P73? We are very much aware about P53. It is I would say a guardian of the genome, where we study that in majority of the cancers, we see that there is a 50% mutations that is observed in P53. But very recent very less light has been shown on P73. P73 belongs, P73 belongs to the P53 tumor suppressor family only, in which we have 3 family partners, that is P53, P63, and P73. But P73 is found to be rarely mutated in cancers. So what is our strategy is that how we can use P73 as a therapeutic intervention when P53 is mutated in majority of the cancers. So if we look at the structural morphology or homology study, we see that P53 and P73 share many domains. And what is more interesting to look into is that P53 and P73 can regulate those genes as well that are P53 dependent, as well as P53 can regulate both the genes that are P73 dependent or P73 independent. So thus it makes a very interesting target to give a therapy where we see that in 50% of the cancers P53 is mutated. So now what we were looking into were the novel long non-coding RNAs. As we know that long non-coding RNAs, as the name suggests, they do not have any protein coding capability and they are less than 200 nucleotides. So what our important concept is, we study the central dogma, where we see that we have replication, we have transcription, we have translation. And we study from our class 11 or class 12 that there is a regulation of gene expression at all the levels, at transcription, at post-transcription, and at translation level. And what is more interesting to see that these long non-coding RNAs, they regulate at both transcription, post-transcription, translation, and most importantly, epigenetic modification that we are looking into to give the treatment at the epigenetic modifications where our genetics do not work at all. So they are at the very first go, they are the chromatin modifiers. So in my subsequent slides, you would see that how they act as a chromatin modifiers also. So now If we move to the next slide, we see the majority of the long non-coding RNAs that have been studied in majority of the cancers. So these long non-coding RNAs, they could be in the chain of, we know that in cancer, there is actually a game of tug of war, where we see that proto-oncogenes, if activated, turn into cancers. And if now the thing depends who will win. So long non-coding RNAs have their equal weightage. These long non-coding RNAs can target those genes also that can give rise to tumor in the body, or they can act in the chain of tumor suppressor. So our lab studies both long non-coding RNAs, where we see that how these long non-coding RNAs regulate at the chromatin level, giving the stretched tumor suppressor gene or oncogene effect. So now, what was our rationale? Our rationale was to look into the P73 regulated novel long non-coding RNAs. And yes, today I'm not discussing, but we also looked into the effect of escalatin, that what is the effect of escalatin anti-cancer drug on these long non-coding RNAs. So what was our strategy? We had HCT116P53 null P73++ and P73 knockdown cell line. P73 knockdown cell line has been made in the lab, wherein the puromycin pooled cells have been collected and stable transfection has been done. So we give the etoposide treatment, as we know that P53, these tumor suppressor proteins are at a very less concentration. We need to give, like in our body, in natural phenomena, there is a DNA damage that activates them. But in the lab, we need to give etoposide treatment to activate P53 mRNA or at the protein level. For that, we give etoposide treatment for 24 hours. That has been standardized. We isolate the RNA, we prepare the cDNA, and then semi-quantitative PCR to check the number of cycles. Then we perform the real-time PCR. Then we did the expression analysis. First of all, to check that in moving an experiment, yes, P73, in any way we say that in P73 knockdown, there is 70% knockdown effect of P73. But yes, every time we need to check the expression of P73 by any chance, by culturing of the cells, P73 knockdown should be maintained. So now, what we did, we outsourced this RNA-seq. We actually outsourced this to the company, where we got the RNA-seq data, and we find n number of protein coding genes and microRNAs, long non-coding RNAs. So we every strategy is working on protein coding genes. So we were interested to look into the long non-coding RNAs. So what was actually there was differential regulation of long non-coding RNAs, where we see that some of the long non-coding RNAs were upregulated and some of the long non-coding RNAs were downregulated. In P73 knockdown, some long non-coding RNAs were upregulated. So it means that these long non-coding RNAs are oncogenic, because in P73 P73 is having two forms, that is transactivation form and double negative form. Double negative form moves that P73 to oncogenic effect, and P73 transactivation form move it to the tumor suppressor. So these long non-coding RNAs, that long non-coding RNA 1, 2, 3, that is ZFPM to AS1, PVT1 and MIR100HG. These are upregulated in P73 knockdown cell line. So after that, we got majority of in our heat map cluster, we got majority of the genes that were upregulated and downregulated. So we wanted to see actually, first of all, the expression of P73, and we find that in P73 knockdown, we have decreased expression of P73. It means that we can move ahead and look into the novel expression of all these genes. And real-time PCR performed to check that whether these long non-coding RNAs that were given in the data that was provided by the company, that whether these long non-coding RNA are actually upregulated or not. So we looked into the relative mRNA expression through real-time PCR, as you can see in the graph, like ZFPM to AS1, MIR100HG and PVT1. All these long non-coding RNA were significantly expressed in P73 knockdown cell line. And GAZL1, LINK011108, LINK00324, these long non-coding RNAs were downregulated in P73 knockdown cell line. So moving towards the P1 are oncogenic, P1 that has been shown they are in tumor suppressor in function. Now, what was our next curiosity to see that whether the promoter of these long non contain any chance the P73 binding site. For that, and Jasper software, we check that whether there is a P73 binding site on these long non-coding RNA promoter. So through bioinformatics analysis, we find that they include the P73 binding site, but we use the term putative for the next to To pinpoint that, yes, this is the binding site, we perform the luciferase assay, wherein the promoter construct of these long non-coding RNA genes are cloned in the vector, and then the transfection is done and checked through luminometer. Yes, we find that these are actually the P73 binding site that we were saying as putative. So now, very interestingly, if I give 2 minutes to this slide, actually P73, P53 and SYN3, a major chromatin modifier, has been known to interact in 1985 by Murphy. So we were very interested to see that whether P73 and SYN3 also interact with each other. We performed an initial experiment to see that whether P73 and SYN3 interact through co-immunoprecipitation, and yes, we should say like P73 and SYN3, they both interact, both the isoforms SYN3A and SYN3B. So now what was our main curiosity? Like what we say that P73 is binding on to the long non-coding RNA promoter. So now what we wanted to see that whether P73 should be using one or the other chromatin modifier to either upregulate or downregulate these genes. So P73, what we find that P73 was using SYN3. We use the chip assay, that is chromatin immunoprecipitation, wherein we pull down the chromatin with our antibodies and we use the primers against the long non-coding RNA promoter. And through this, it gives us the 100% proof that whatever we were saying as the putative binding site at P73 was binding to long non-coding RNA promoter. Yeah. So I'm writing it. So now we were very interested to look into the long non-coding RNA effect on the effect of escalatin on long non-coding RNA, and all these long non-coding RNA studies are still going on, or the effect of escalatin on long non-coding RNA. But PVT1, one of the long non-coding RNA, has shown to give a very drastic decrease with the effect of escalatin. Why? Because if we look into the strategy, escalatin as a drug uses WNT beta catenin pathway and PVT. If we look into this particular location, PVT is just located 53 base pair just away from the c-MYC, and all the studies of c-MYC have been very clarified. So we wanted to look into that how actually PVT and c-MYC, they form a gene desert kind of condition where there is no protein coding gene, but still PVT1 is increased in the cancers, and escalatin has shown to show an effect through WNT beta catenin pathway. So we are further studies needs to be done that how WNT beta catenin pathway needs to be studied. So thank you very much.
The time is up. Do you have any questions? Any question from audience? Thank you.
Thank you.
Thank you, everyone. Thanks to all the participants, and wish you all the good luck. We'll get the result by tomorrow evening, the winners. And that's all for the day, for this session. Thank you. What?
So the session is over. So thank you, chairpersons, Professor R.K. Negi and Dr. Vivek Singh for chairing the session. And also I would like to thank all the participants for coming and presenting their work. So I would request Professor R.K. Negi and Dr. Vivek Singh to receive their memento. So I request Professor R.K. Negi to give the memento to Dr. V.K. Singh. Thank you so much, sir.
Hello, check. Hello, check. Hello.
Good afternoon all. My name is Anshul. I'm a research scholar from Department of Biophysics working under the supervision of Dr. Simran Preet. She's an assistant professor there. So today I'm here to present my part of research work entitled Combinatorial Efficacy of Human Intestinal Defensin 5 and 5-fluorouracil against 1,2-dimethylhydrazine dihydrochloride induced colon cancer, a double-edged sword. So let's start with the anatomy of colon. As we all know that colon is a part of large intestine and it has several tissue layers, that is starting from mucosa, submucosa, muscularis externa and serosa. But if we talk about the colon cancer, colon actually develops in the form of small polyps. So those polyps can be cancerous as well as non-cancerous. That's where the colonoscopy play a major role. And in colonoscopy, what does they do? They just excise the polyp and then further assess it for the malignancy. So after, if the polyp is malignant, then it converted into adenosarcoma and then the full-grown tumor. Next, the various risk factors involved with the colon cancer are age, precancerous polyps, family history, inflammatory bowel disease, and if you're having lots of red and processed meat, then you could be at a risk of having colon cancer. The next is the heavy alcohol consumption, diabetes, smoking, obesity, sedentary lifestyle. And these are the various symptoms that if you are having a blood and stools, unexplained weight loss over a time period, diarrhea, stomachache, constipation. So these are the various symptoms. And further, these are the diagnosis tests associated with the colon cancer. Now, if you talk about the India against colon cancer, so these are various reports, which are recent reports, which are reporting that in India especially, the colon cancer rate is increasing year by year due to our sedentary lifestyle and poor food habits. And as stated by the Professor Govind Makharia, Secretary General of Indian Society for Gastroenterology on 30th May, that with no data and studies on the prevalence and the burden of the disease, India would be at the crossroads. So presently we are having various treatments available for colon cancer in India. First is the surgical resection, that is the simplest procedure where the malignant tumor has been removed. Second is the cryoablation or radiofrequency ablation. Third is the radiation therapy. Next is the colostomy. And the gold standard treatment is chemotherapy, where the patient have been administered with a single agent, a single chemo drug agent, or even in the combinations. So these are the single agent, and these are the combination, which FOLFIRI and FOLFOX are the major combination treatments, in which 2 chemo drugs with a micronutrient has been administered. So next is, though it is a gold standard treatment, but it is again associated with severe side effects involving diarrhea, foot and hand sores, mouth ulcers, loss of hair loss, compromised immunity, non-specificity towards the cancerous cells, invasive, and for most, it is invasive in nature and it requires multiple cycles for the treatments. So that is very burdensome for the patients, and patients often miss their cycles. Next is the recurrence of tumor. And last is the multi-drug resistance, which is nowadays becoming the most important factor with the failures of chemo drugs. So in this case, I have been studying on AMPs, antimicrobial peptides. Basically, these are cationic in nature. So they are highly specific towards negatively charged cancer cells, because cancer cells are possessing heparin sulfate, sialic acid, and negatively charged phospholipids on their outer leaflet, which are otherwise absent in the normal cells. So they are highly selective. So they just select the cancer cells, leaving the normal cells unharmed. So that is the rationale behind my study. And for AMPs, they have low toxicity. They have good tissue penetration because they are in smaller size. Then they have good efficacy and safety, and they have broad spectrum properties towards bacterial cells, viruses, and even against cancer cells. And lastly, cancer cells possess no resistance towards these AMPs. So in my study, I selected human defensin 5. Actually, human defensin 5 has been secreted by the painted cells present in the crypts of the intestine. It is a 32 amino acid long peptide having 3 disulfide bonds. So this is my experimental group, which I have taken for my study. And this is the experimental scheme. For 16 weeks, I have administered DMH to the animals, and after assessing the CEA and CA19-9 levels, that are the markers for colon cancer, then I started my therapy with 5-FU and human defensin 5. So my first objective is to evaluate the effect of human defensin 5 and 5-FU combination against DMH-induced colon cancer in terms of tumor morphometrics, tumor biopsy, aberrant crypt foci, histo architecture, and electron microscopy. So in first part of the figure, you can see the development of colon tumor. So before initiating my experiment, I have actually developed colon tumor and dissect the animal so that I could be very much sure of my model. So the B part is actually after 10 weeks of DMH administration, we can see angiogenesis and inflammation, and C and D are after the 16 weeks of DMH administration. And these are the gross tumor morphology in my treatment groups, where C, D, and E are actually HD5 therapy, D is 5FU therapy, and E is HD5 plus 5FU combination therapy groups. And if you talk about the tumor morphometrics, so in the tumor multiplicity, tumor burden, and tumor incidence was highly reduced in case of combination group. And in case of aberrant foci, you can see darkly stained aberrant foci in case of untreated DMH group, whereas in D and D, that is the combination in 5FU, these are stained lightly with the methylene blue. Next is the histo architecture. Same in the case of histo architecture, untreated DMH group show eroded surface with no presence of colonic epithelia, whereas in case of combination, the restoration has been found. And if you talk about the scanning electron microscopy, in the second figure, this is after 10 weeks of DMH treatment. So you can see the formation of a tumor there. So after complete formation, you can see the surface of the untreated DMH has been completely eroded with presence of no crypts over there. But in case of combination, the crypts formation is started to restoring itself. Next, I have evaluated the apoptogenic potential of my combination. And in case of combination, maximum apoptotic bodies was evident as with stained red fluorescence with Alexa-Fluor, and the blue one is with the Hoxt. Next, I have evaluated the mucopolysaccharides, the extent of mucopolysaccharides, concentration of because they are the main agents that prevent the intestinal mucosa from damage from pathogens, even from the carcinogenic compounds. So you can see that A part is from the past staining, and the second and third are basically the acidic mucopolysaccharides. So magenta is the basic polysaccharides, and blue one are the acidic mucopolysaccharides. And in case of untreated, these are lightly stained because of the lesser concentration, whereas in case of combination, these are darkly stained. Next, I have studied the membrane electric potential and lateral phase separation and various transcriptional factors. So in case of untreated, I have isolated colonocytes from my animals for this particular parameter. And in tumorous colonocytes, the cells actually stained very much intense with MC540, whereas in combination, this extent has been reduced due to the increase in the fluidity of the cells. Further, I have evaluated the expression of P53, that is a tumor suppressor gene. And in DMH, untreated DMH treatment, you can see the downregulation of this particular gene, whereas the BCL2 is also anti-apoptosis that is upregulated in the untreated DMH group, and BAX and cytochrome C, that are the pro-apoptotic genes, which are highly aggregated in combination treatment. Next, I have studied my combination with human CACO2 cell lines, so that I can be sure that it is actually working with the human cancerous colonic cells as well. So for that, I have directly studied the interaction of cells with the peptide and chemodrug combination, where you can see the vacuolization and as well as the damage of the cellular membranes of the CACO2 cells. And even in MTT assay, my IC50 of HD5 and 5FU has been reduced half to its original concentration when they were used alone. Next, I have studied the effect of HD5 and 5FU combination on 5FU resistant CACO2 cell lines, which was developed by me only. I have taken the CACO2 cell lines and create resistance of 5FU with a continuous incubation of the 5FU above the IC50 level. So for that, I have done a flow cytometry assay to study the apoptotic potential, whether my peptide and chemodrug are now could bring apoptosis in resistant cell as well. And you can see that in the combination group, a very good number of apoptotic population was observed. And similarly, in the transcriptional levels, MDR1 gene, that is the PGP, that is the gene for the PGP protein that is highly expressed in resistant cell lines, is very much upregulated in my 5FU resistant CACO2 cell lines and downregulated in my treatment groups. So this this particular publication was seen because I have already established HD5 as an anti-cancer agent. Then my next step is to use an adjunct with a chemo drug so as to reduce the effective dosage of 5-FU, thereby reducing their side effects and thereby combating the multi-drug resistance. So with this, thank you so much.
Any question from the audience? So, kind of peptide, no?
Yes, it is a host defense peptide.
So there could be different isoforms, I think, so, because it's different in size. No?
Yeah, sir, there are two forms. One it is inactivated and one is activated. In the Pennant cell, it is present in inactivated form. Very interesting thing about is the protein. The proteases that is present in our intestine actually cleave it and form it in an activated form. So I have taken the sequence of the activated HD5.
Okay. So enzymes basically are involved in activating some of the enzymes, no?
That is, that is involved in our body, but the sequence that I have taken for my study is the activated form.
So whether this defensin 5 is working directly on the cancer cells?
Yes, sir.
Or through activating macrophage and dot, because it's kind of peptide means how it's doing that.
Sir, the publication.
It's small peptide, no?
Sir, can I show a slide because I know that question might be come. So this is my work from the publication which I have shown. Here I have shown the direct interaction of HD5 with colonocytes that have been isolated from my normal rat and from a cancerous rat. And here you can see the membrane blebbing where the tumorous colonocytes been incubated with HD5. That is the A4th figure of phase contrast microscopy. This membrane damage was just even the 20 minutes of my incubation.
Okay, and another question is that because inside the body, if there is a cancer, then acidification going to
yes,
obviously means because tumor cells are going to produce lots of lactate and other metabolites. So have you checked whether the stability of this defensin 5 is going to be affected by the pH? If pH is going to be.
Yes, sir. I have checked its stability at different pH of the cancerous cells because in cancer, the pH level goes to 6.5. And in normal flora, that is about 7 to 7.2, especially in our intestines. So I have mimicked the intestinal environment and then checked the activity of HD5 in it. And furthermore, I have checked its stability even in the serum, plasma, and complete blood itself. And further, I have tried to do the biodistribution and pharmacokinetic profiling of this peptide also, but I have getting a problem in that because it is a short peptide. So that is.
So last question. So this is peptide. So can you tell me which are the amino acids which are basically involved in doing all these things?
Sir,
do you have any idea?
Yes, sir, because it is a very arginine-rich peptide. Actually, it is a cationic nature due to presence of large number of positively charged amino acids. So that plays a key role because that provided the function of selectivity towards cancer cells. And it has a potential to take intrinsic pathway of apoptosis. That I have already checked. Intraperitoneal.
Okay, the next presenter is Aspir Kaur.
Good afternoon all. My name is Arshvil Kaur and I am PhD scholar from Department of Pharmacology, Dipsar, New Delhi. And this is a part of my PhD work, a sort of preliminary work that has been done, and it is titled as unhindered fructose drinking, exposure to EMF from mobile phones, and DMBA in adolescent and young adult female rats, correlates for early onset and higher incidence of mammary tumors. So as you have seen the title, I am discussing here the effect of 3 factors that are our lifestyle or environmental factors like EMF from mobile phones, fructose drinking, and a chemical carcinogen DMBA in this. Globally, we all know breast cancer is the most common cause of mortality in women, and it is now being not restricted to only developed nation, but also the developing nations are being engulfed in this. Also, it is not restricted to the pre or post-menopausal stage. The age group is now being shifted to the adolescents and youngs. So in India, Delhi is having the higher incidence rate, along with its the mortality rate is also associated. And the other factors are like early menarche, late onset of periods, or late menopause, or the genetic predispositions can be the causes for this. But here I'm discussing the novel environmental and lifestyle factors. Out of these 3, DMBA, we all know, is the most commonly used chemical carcinogen for the induction of mammary tumors in laboratory rodents. Then mobile phone radiations are there. That has become the indispensable part of our life, and we are bound to use it. Then is fructose-induced insulin resistance or the metabolic dyslipidemia. Now we cannot escape from the exposure to DMBA. That is a part of the smoke released from burning of the rubbish material, industrial effluents, then also the cigarette smoking. We cannot leave mobile phones, and also 40% of the sweetener includes fructose in this. And the various studies also support the involvement of these factors. But the question here arises how these 3 factors as a whole shifting the age group from the post-menopausal age to adulthood or the younger ones in causing mammary tumors. So for this, I had 2 objectives in this. First was to study the concomitant role, in which I have studied the tumor characteristics, that is the onset of the tumors, then it's the mortality rates, associated survival, then is the mitochondrial damage, that is with the use of TAM analysis. And second is the role of insulin resistance, as fructose is involved in this. So how insulin resistance is becoming a major cause for the shifting of this age group from post-menopausal to the younger age. The study was designed for over the period of 18 weeks, in which the rats were given unhindered supply of fructose 15% solution ad libitum. Then they were also exposed to the mobile phone radiation using this specialized apparatus, in which a motor controller software was there, and a perspex cage was there in which rats were placed, and it was connected with the stepper motor with the help of a thread. And perspex cage was selected because it only allowed the non-thermal radiation to pass through and doesn't allow the heating effect to take place. And we are focusing here over only the non-thermal radiations that lead to biochemical changes. Study was duly approved by the IAC committee of DIPSRU, and there were 2 groups. One was the animals who were given only DMBA for 30 mg in a divided dosage for over the time period of 6 weeks from the starting of the study. And then another group was there who was given all the 3 environmental or causative factors. Then during the study, the tumor characteristics were studied, weekly FBG was done, their normal recording of physiological parameter was there, and via palpation, the tumor size and volume was also noted. And on pre-terminal basis, we have studied the insulin resistance parameters, that is OGTT, ITT. Then the impairments in lipid profile and liver function was also studied. Physiological, you can see clearly the animals who were given fructose, they have their dependency over the energy intake from more of the fructose solution as compared to the food. As compared to the DMB animal, they were taking whole of their energy from the food only, and the FRC group, or you can say the fed group, was taking more of their energy from fructose. They were dependent on that because of the tumor progression in that case. body weight of the fed animal was less initially, but till the end of the study, they tend to show the growth in the body weight as compared to the DMBA animals. And we also can say that the person dependent on fructose, they also become somewhat addictive to that over a long span of usage. Insulin resistance parameter says that towards the end of the study, there was not a significant change in IBG, but still the fed group, they tend to start the show the rise till the end of the study as compared to the DMBA group. And then also the OGTT and ITT. In case of OGTT, the DMBA group has shown the poor tolerance against the carbohydrate. In case of fed groups, they have shown the resistance to insulin as the area under the curve in that case tend to increase despite giving the extraneous insulins to them. Then tumor characteristics, you can see here the image of a palpable tumors in the rat that was observed on a weekly basis after giving the last dose of the DMBA starting from the 45th day of the study. Then you can see the tumor burden was more in DMBA as compared to fed, that is the weight of tumor per rat. But incidence tend to be higher in case of fed group, where both EMF and fructose were working. Along with that, it has contributed to higher mortality rate in that case. And also you can see the latency. The latency has reduced in case of fed group. That is, the tumor onset was earlier as compared to DMBA. You can say the day 86 was this average time span for the initiation of tumor in case of fed as compared to the DMBA group, in which the tumor started after 100th day of the study. Then you can see the survival analysis. In that case, the mortality rate was higher in case of fed. So you can say maybe the tumor size can be less in case of fed, but onset was earlier and mortality was higher in that case. Then you can also see in relation to the lipid profile and lipid liver function test, SGOT was higher in case of fed, and triglyceride and cholesterol was also higher. That show the increased cardiac risks and the onset of the metabolic syndrome, or you can say the metabolic dyslipidemia has initiated in that group. In case of TAM analysis, you can see the presence of more of mitochondrial damage in case of fed. More microvilli were there, cellular damage was there, and more of vacuolization. But in relation to DMBA has shown the presence of lysosomes in that show the metastasis and invasion is more in DMBA. So as a whole, we can correlate this study with the onset of insulin resistance in case of mammary tumors and increased cardiac risk in the fed group as compared to DMBA. So definitely these two are the contributing factor for this early onset. And also we can go for more deeper study like cell cycle analysis, hormonal expression to have a deeper insight in that case. And in the end, I would like to thank my supervisor, Dr. Rajni Mathur, Department of Zoology, Delhi University, for giving me this task. And without the financial assistance from ICMR, this work would have not been done. Thank you so much for the patience. Yes, sir. Sir, actually, you're right that cancer cells, they need glucose as a fuel. They tend to absorb more and more glucose and create a microenvironment which is glucose deficient and is not suitable for the survival of the cells. But fructose has the ability to escape from the metabolism by insulin. It can escape from the rate limiting step from the carbohydrate metabolism, and that is why it is easily metabolized in the body. And when there is glucose deficient state, fructose is only the second most nutrient that cell tend to absorb and survive. And also fructose help in generation of more and more lactic acid and uric acid. How? By suppressing the mitochondrial respiration and by favoring the aerobic glycolysis. So this acidic environment also favors the survival of cell and aids metastasis and invasion. So that is why fructose can be used in the study, and also like glucose, fructose can also lead to insulin resistance. Yes, sir. Yes, so that is included in our upcoming objective that is not discussed here, and that is under the study only. For glucose, the main transporters involve GLUT2 and GLUT4. And for fructose, it is GLUT5. GLUT5 is not normally expressed in the cell. It is only upregulated in the cancerous cells. And initially, we didn't have sufficient data for its overexpression, but now fewer studies are there which are reporting that in tumor cells, GLUT5 is also overexpressed. That also emphasizes the role of fructose in this type of tumor generation. Yes. Yes, sir. Along with this, cancer cachexia is also seen, but in this case, two factors are there. One is EMF and one is the fructose. EMF is also known to cause fatty liver. It can lead to pancreatic cell damage. It can lead to changes into the liver cells and liver functioning. And fatty liver is associated with the role of EMF. So you can say that EMF is also contributing here to the insulin resistance, and you can say the weight gain in that case. For that, what we can do, we can go for appropriate control in which we can study separately fructose with DMBA and exposure EMF with DMBA. That will give a clear picture. As I have seen in the sacrificed animal, the visceral adiposity was more. Visceral adiposity was more in that case. Thank you so much, sir.
Good afternoon, everyone. I am Kulbhushan Thakur. I am a PhD research scholar in Department of Zoology, University of Delhi. I am doing my PhD under the supervision of Professor Alok Chandra Bharti. So today I am presenting a part of my PhD research work, the topic entitled Dissecting the Direct and Indirect Interactions of STAT3 with Human Papillomaviruses and its implications in HPV transcriptional control in cervical carcinogenesis. Cervical cancer is the major cancer among the women in the developing country. It ranks 4th globally, and if we talk about the Indian population, it ranks 2nd. So the causative agent for this cervical cancer is the persistent infection of human papillomaviruses. So the human papillomaviruses are the double-stranded DNA viruses. If you look into the biology of this virus, there are two proteins, E6 and E7. Those are the oncogenic proteins. They cause the tumorigenic transformations in the host microenvironment. So the virus alone itself is not capable of doing this whole event. There are the involvement of certain host transcription factors. If we look into the biology of or the genome structure of this virus, the LCR region in the viral genome is the interface wherein number of host transcription factors bind and cause the upregulation of further downstream genes, which is E6 and E7. So far, there are many transcription factors reported on those bind onto the LCR of this virus. However, the genomic location or binding of this STAT3 is not yet investigated. Why STAT3? STAT3 is oncogenic transcription factor that has been found upregulated in many tumorigenic transformations, including cervical cancer. Previous reports from our laboratory have shown that with the progression of the disease, this cervical cancer, the level of this STAT3 transcription factor increases. So is the increase in viral load. So in the present investigation, what I have done, we have investigated the direct or indirect interactions of this virus with this transcription factor with the viral genome. Previous reports have talked so much, our previous reports have talked so much about this transcription factor, its role in cervical carcinogenesis. So from there we concluded that it is a master regulator that plays role in HPV persistent infection, maintenance of its copy number, integration frequency, and transcription regulation. But there are certain key questions. Today I am addressing this one key question as to how this STAT3 is interacting with this HPV genome. Is it directly interacting with the HPV genome, or there are certain indirect interactions? So to address the first objective, which is the direct interactions, we did certain in silico analysis, including the manual analysis of LCR region of HPV16 genome. Then we extended our study to the experimental validation with the chip-based analysis. STAT3 recognizes a particular sequence, which is the TTAA in the flanking regions, and in between there are 4 to 6 base pair sequence, variable base pair sequences. So we looked into that consensus sequences and found that there are certain 4 base pairs, 5 base pair, as well as 6 base pair sequence that might present in the HPV16 LCR region. Further, we did FEMO analysis, which is in silico analysis, and we found, and there are 20 sites and 17 sites in HPV18, 20 in HPV16, and 17 in HPV16 sites, motifs that could where the STAT3 can bind. However, these all in silico analysis need experimental validation. So for that, we did chip-based analysis. We did chromatin immunoprecipitation. So we did chromatin immunoprecipitation with HPV16 for HPV16 LCR region. We designed the primer for HPV16 LCR region, and we did the chip analysis. However, we failed to detect any STAT enrichment in HPV16 LCR region. There are certain previous studies that have also talked about STAT3 binding. They said that there is no direct binding of STAT3 on HPV18 genome. We looked into the HPV16 genome. They said there is no direct binding. So they also proposed there might be any indirect interaction of STAT3 with viral genome. So here we summarize our first objective as to there are multiple sites on the HPV16 and LCR region. Those were proposed those are proposed for STAT3. However, the experimental validation lack any STAT3 binding on HPV LCR region. The next question arises, does STAT3 interact indirectly with the HPV LCR? So for that, we again started with in silico analysis of different transcription factors that bind on the HPV LCR. And why different transcription factors? Because we have recently reviewed that there are a number of transcription factors that can bind on LCR region and also reported experimentally, but not STAT3. So we picked all those transcription factors and did this string analysis to find whether the STAT3 is directly interacting or physically interacting with those transcription factors. So we came up with the conclusion like there is CJUN and CFOS. Those were the 2 transcription factors. Those were strongly interacting with the STAT3. CFOS, CJUN made a very, they are proven oncogenic transcription factors, and their role has been proposed in cervical cancers also. But here, this physical interaction that we are investigating is not reported yet. So we looked into this physical interaction. We did co-immunoprecipitation analysis in order to find the physical interaction of this STAT3 with CFOS and CJUN, and we found that STAT3 was physically interacting with CFOS and CJUN not only in HPV16 positive cell lines but also in HeLa, which is HPV18 positive cell line. So reversibly, we checked that CJUN was also physically interacting. So this was cross-checked basically. The co-immunoprecipitation confirmed the physical interaction of STAT3 with CFOS and CJUN. Now, another question arises, what if we alter the expression of this STAT3? Are these oncogenic transcription factors, CFOS and CJUN, also getting altered? And what about What about the localization? What about the expression of viral oncogenic protein that we are talking about, E6 and E7? So for that, we did ICC immunocytochemistry, and we found on increasing the expression of STAT3 by the introduction of this IL-6, we found the increase in the expression of this CFOS and CJUN in HeLa and CHAPA cell lines. We also, the expression of was also quantified, and we found that the increase in STAT3 was concordant with the increase in this CFOS and CJUN, and upon the inhibition of STAT3 with static, we found the expression of CFOS and CJUN was also downregulated. Not only CFOS and CJUN, I was talking about viral oncoproteins, so we also checked the expression of altering the expression of STAT3 in the alteration of HPV16 oncoproteins. So we checked the expression of HPV16 E6 and E7, and we found upon IL-6 introduction, the expression of E6 and E7 was increased along with STAT3. And when the STAT3 was suppressed with static, the expression of E6 and E7 was also suppressed. The similar study was conducted in HeLa cell lines, and the results were the same. So from there, we were thinking of looking into the biomarker approach. So what we did, we analyzed the large transcriptomic data set that included around 305 patients. And what we found on TCG database, the Cancer Genome Atlas, and what we found was the expression of CJUN was differentially upregulated in HPV16 positive cell line, and as the Kaplan-Meier analysis indicated, the higher expression of this CJUN was associated with the poor survival. From here, we concluded that there is a direct interaction of STAT3 with the AP1 family proteins, those are CFOS and CJUN, and they are forming a physical complex. This complex might be interacting with this viral genome in order to alter the expression of this E6 and E7. And further, this upregulation of E6 and E7 regulate the expression of these oncogenic transcription factors. Thank you so much. Sir, I have also investigated the expression of STAT1, STAT3, and STAT5. So my lab has been working on STAT3 already, but I was also keen to see the expression of other isoforms. But I came up with the conclusion like STAT3 is the only, along with STAT5, but not STAT5 is not to that extent was significantly upregulated, but STAT3 was found significantly upregulated in this malignancy, which is cervical malignancy. Moreover, our laboratory has been working on this since a decade. So there are several reports from the lab stating the role of oncogenic role of this transcription factor in cervical malignancy. That's why this was the gene of interest. Sir, I have not presented it here. There was another objective wherein we investigated the complex, that is JAK-STAT signaling complex, targeting the 84 genes from that complex, JAK-STAT complex, in the cervical biopsies, tissue samples. So what we did, we investigated the expression of those JAK-STAT signaling related genes. That was another objective I have not presented here. So from there also these gene, another gene, there were 7 other genes also I have not presented here. So yes, but not other STAT1 or STAT3, because also there are other reports stating STAT1 is the inhibitor somewhere to this STAT3. They have antagonistic role in that too in cervical malignancy. What part of your work you are presenting here? this is my presentation only. This is my PhD work. There are two objectives that I have presented. I have not presented another objective. That was, these are actually, this is unpublished data. So this is open for any discussion. I can get reviews from the public and the audience in order to improve my study. Making it phosphorylated. I have not read about the like physical interaction is helping the phosphorylation of STAT3. I have not read any study like wherein a protein is interacting with STAT3 physically and helping it to phosphorylate. So what else we can do is, we were thinking of extending this study with the activated STAT3. Like I have here investigated the role of total STAT3, its association with the C4 and C-Jun. I am thinking of extending it with phosphorylated STAT3. What if the activated STAT3, because ultimately there is the role of activated STAT3 that is binding to the genome of the LCR. So I was thinking of extending it with phosphorylated STAT3, repeat with phosphorylated. Thank you, sir.
So drawing from this short study, the conclusions that we have drawn are the upregulation of Claudin 4 and the downregulation of Claudin 1, and then the twofold increase change in the levels of Claudin 4 at the cellular level, and also this is also new. This is a new report. The interaction of ESPG with non-muscle myosin 2A. So basing that with our team, what are the possible conclusions or the take-home message we can take from this is that this the breakdown of these dijunctions occurring and then their interaction studies will help to understand and intervene in the different and develop strategies to reduce or minimize their effects, the effect of the disease on the host organism. So thank you. Sir, there's still more of than this is preliminary studies. So, so far what we are seeing is that Claudin 4 is being upregulated. And then I've not mentioned here. Yeah, that's also a good question. That's a good question, sir, because in the case of other effector proteins, say F or MAP, in the people in the work that have in the lab that have worked on this, in both the cases, in the case of MAP and in the case of ESPF, both Claudin 1 and 4 are downregulated in their cases. But in the case of ESPG, as per reported literature, it states, it is that both Claudin 1 and 4 are down. But this is what we have observed, and then yes. So whether this so actually, yeah, for that, this is actually we have also done study. Though I did not present here on the different endosomal markers and then their relation, because actin being the actin myosin motor being a core motor protein, apart from the microtubules, there could be possible interaction of this role of this ESPG interacting with myosin, and then in a certain way affecting this Claudin 4. Or another hypothesis could be that the half-life of Claudin 4 is reduced in the case of ESPG expressing condition. That could be either at the protein level or at the transcriptional level. That's those are the work that are currently in the pipeline. In the process. Claudin 1 and 4, they are under the same family of Claudin, the tetraspending proteins in the junction. So they share similar homologies, but they also have different distinct homologies, because Claudin 1 is and Claudin 4, they are not necessarily expressed together in certain cell lines. And for example, in the case of endothelial cells, Claudin 5 is expressed majorly. However, Claudin 1 and 4, they show around 37, I guess.
Good evening, one and all present here. To myself, Pooja Yadav from Department of Biochemistry, Central University, Rajasthan. Today, I'm here to present my work on the topic identification of common inhibitors for DNA methyltransferase 1 and S-adenosyl homocysteine hydrolase through virtual drug screening. Before start, I would like to give a brief intro about the DNA methylation, DNMT1 and S-adenosyl homocysteine hydrolase. However, cancer is a disease of the genome, but only genetic changes as well as epigenetic changes both play a role in the tumorigenesis. Here we will focus on mainly on the breast cancer. And from the literature, we have also seen that DNMT1 is one of the factors enhancing the TNBC tumorigenic potential, as well as increased HCY expression plays a role in enhancing DNMT1 activity. So in our study, we will explore the mechanism behind the expression of the AHCY and DNMT1 regulation that can provide as a new promising therapeutic aspects for cancer prevention. First, we have analyzed the DNMT1 expression status in pan cancer, and we mainly focus on the breast cancer. We find that the DNMT1 expression is upregulated in most of the cancer types, including the breast cancer. It was validated from the GPR2 server. Further, we focus on the AHCY also, because from the literature, we find that the AHCY can degrade the inhibitor of the DNMT1 and activates the DNMT1 activity. So we check the AHCY expression and find that the AHCY upregulated in some of the cancer types, including the breast cancer. Further, we check the DNMT1 as well as AHCY expression in breast tumor tissues. And we find that in malignant breast tumor tissues, DNMT1 as well as AHCY expression both are upregulated. After that, to see what is the clinical features of AHCY, in our another work, we have already studied about the DNMT1 can increase the migration potential, invasion potential, and the stemness potential of the breast cancer cell. So here we see what is the impact of AHCY on the age, gender, and the different subtypes of breast cancer. And we see that in the male patients of the breast cancer, the higher expression of AHCY as well as in the p53 mutants, AHCY is upregulated. Further, from the survival of the HCY protein, we find that the hazard ratio is higher than the 1, indicates that the HCY higher expression in the breast cancer patients shows the poor prognosis of the patients. It was also validated from the GPR2 and that in the luminal A subtype have the lower expression of the AHCY as compared to the basal and the HER2 positive breast cancer subtype. Further, from the KM plotter, we also find that in the lung cancer also HCY upregulation indicates that the poor survival of the lung cancer as well as breast cancer patients. That means that we can find that AHCY gene as a potential gene for the prediction of the prognosis in breast as well as lung cancer patients. Now our focus on the DNMT1 and the AHCY link. And from the online server, we find that the AHCY and the DNMT1 are positively correlated, and AHCY degrade the DNMT1 inhibitor SH. That's why DNMT1 activity will be increased. Now, after that, we find a link that both the genes are linked. Then further, we want to see how the DNMT1 as well as AHCY are endogenously regulated inside the breast cancer cells. In our study, so we focus on the main two pathway, cholesterol pathway and the BMP2 signaling. And we find a positive link between the DNMT1 expression at the transcript level with the main regulatory genes of the cholesterol pathway and the BMP2 factors. After that, we see how the HCY is correlated with the main regulatory cholesterol genes and the BMP2 regulatory BMP2 signaling factors. Both are the positively correlated. Then it was validated from the RT-PCR and the Western blot. we use the simvastatin, that is a non-inhibitor of the cholesterol pathway, and BMP2 signaling. For the BMP2 signaling, we treat the breast cancer cells, MDMB and the CF7 cells with the BMP2 and find that the DNMT1 expression at the transcript level as well as the protein level can be upregulated in both the cancer cell lines. But after treating the simvastatin in combination with the BMP2, the expression of the DNMT1 was decreased. That means the simvastatin inhibits the BMP2 induced DNMT1 expression. Further, for HCY, we see at the only transcript level till now and find the same pattern of the regulation of HCY also. That will provide in future some more factors that we can target to treat the to down regulate the DNMT1 expression. Further, our main focus was to find some inhibitor for the DNMT1 that can inhibit the DNMT1 activity and prevent the tumorigenesis. So we performed the in silico docking and select the PDB structure from the PDB data bank for the DNMT1 as well as AHCY, and use a library of 1250 compounds. That library was low-pack library, have some biochemical compounds and give some results on the basis of the docking score as compared to the control compound that was present in both the proteins active site. And we select, by chance we find some common inhibitors in the best on the top showing the docking score. We select the 7 compounds. And these 7 compounds we will take for our future study and need to do some experiments for this. Summary of my work is that first of all, I analyzed the DNMT1 and HCY expression in most of the cancer types, including the breast cancer. And AHCY and DNMT1 both were upregulated in the breast cancer tumor tissues as compared to the benign tumor tissues. From the KM plotter survival analysis, we found that the AHCY is correlated with the poor prognosis of the breast cancer patients and the lung cancer patients. Database analysis shows a positive link, both the DNMT1 as well as AHCY. A link was established in our study between the BMP2 signaling and cholesterol pathway with the endogenous regulation of DNMT1 as well as AHCY. We find some common inhibitors by virtual screening may more efficiently inhibit the DNMT1 activity as well as AHCY to inhibit the tumorigenic effect of DNMT1. Thank you. Yes, sir. Yes, sir. Because the inhibitors present currently, they have some drawbacks like this, so side effects and due to their poor stability. That's why we are to find some inhibitor that is already in market and have some low side effects. That's why we are trying to find some inhibitors. Other than that, we are trying to see endogenous regulation of DNMT1 that will provide some new targets that can target in the another way. Then, so that's why we are trying to
that means the compound directly having some basically enhancing the binding of gamma okay, and it is actually okay. Also you just put that
okay, from literature I have find that the AHCY can degrade a compound SAH that binds in the active site of the DNMT1. And if in the active site of DNMT1 and acts like a potent inhibitor for the DNMT1. In the another way, SAH is a byproduct after the methylation reaction. So if the AHCY is degrading the SAH, that is inhibitor for DNMT1, in the another way, DNMT1 is activating for the another reaction. So we are trying to, if we target both in a way, that AHCY as well as DNMT1. And from the literature also we see that if the DNMT1 is highly expressed, then in the same way AHCY is also increased breast cancer.
This is the lipogenesis, which is the pockets are forming here. is shown in this actually.
Okay, we try to see from the cholesterol and the BMP pathway because cholesterol, as from the literature, we know that the cancer cells. Yes, sir. Yes, sir. So that's why we focus on the cholesterol, and the BMP is the osteoinduced cell. And after treating, in case of the highly increased of the BMP2, the cancer cells trying to be more aggressive. That's why we only see that if the cholesterol is in cancer cells, its cholesterol is more, or we giving the BMP2, then what is the impact on the DNA? So that's why we try to, and already in our lab we have a signaling about the cholesterol and the DNMT1. That's why I focus on.
What we find out is ACL interaction is the autophagic action. And this autophagy, the prolonged autophagy, what we are finding out, and prolonged impaired autophagy as per our molecular. So I come to that. So here basically increases the autophagy.
Professor, because in my hypothesis that can be the reason because SAH degrade the SAH enzyme protein that I have targeted and degrade the SAH compound. That is
but not the so that's why I believe that all biochemical marker and other things that I am not showing here. So that is autophagy and whatever this pattern is JBC, that interaction with several
yes, sir. Many models about both the proteins there is available in the PDB. Yes, sir. Before that, yes, sir. Yes. Yes.
We find out this nanny is very good to use our secondary activity and yeah, actually multiple uses that are secondary activity. We find out that this nanny is what we find out. The nanny so together
thank you all. Indeed, it was a very interesting session and full of scientific discussion. Although the budding scientists did not take part in the discussion, it is unfortunate. If I could remember, Boyer and Cohen they met over in a conference, and then the genesis of a very versatile biotechnology took place. And, anyway, thank you all for your participation, and thank you, Chairperson sir. Thank you for your valuable inputs and precious time. Thank you.
Yeah, so that might actually follow. That's why we are actually pushing this compound in therapeutics as it is in is the diabetic response or obesity, impaired autophagy, or neurodegeneration or aging like that. So that's why we are to move actually in that way. And some of the physiology are not we have that one. How it is, especially the obesity one we are working and model. Next slide will be that one. We will have that slide one. So now actually these are completely like disease, generation, impaired autophagy, that's what we will the and I will okay. And we may get so at the support of what is said of the like so that stop here just I will acknowledge the students plus 10 years